The robot is much like a spider in that it's looking in all directions at all times. The robot may appear to be moving forward or side to side or backwards, but from the robot's perspective, all directions are equivalent. Behind me is one of our electrical substations in Massachusetts. Electrical substation is a facility that takes high power electricity and converts it into lower power for distribution throughout the neighborhood and the surrounding towns. I'm here today with a robot that we're going to use for inspection processes at this substation. We're deploying robots because this operation tends to be very repetitive. We'd like to be able to do this monitoring remotely, and we'd like to have the precision that robotic visual imagery affords us. We need to train the robot in order to perform this inspection. The robot does not automatically know the layout of the site. I need to train the robot to know where to go, what to take pictures of, and in what sequence to take those pictures. This is a fiducial. This fiducial allows the robot to understand where it is and to know where it is in relation to all the other large physical objects in its space. These black and white squares, although they may appear somewhat meaningless to us, is very common within the robot industry. This fiducial here is approximately 14.6 centimeters on each square. The robot knows how big the square is, and it knows the particular pattern of the black and white markings. If the robot sees the square but it appears to be small in its visual field, it knows it's standing further away. If the robot sees the square and it appears to be very large in its visual field, that means the robot is closer because it knows the actual object size is 14.6 centimeters on each square. These black and white squares communicate to the robot what are the appropriate missions that are related to this physical substation and its particular layout. Once it's been trained, the robot can then perform the inspection repeatedly and reliably over time without human intervention. When you look through its screen, you will see, depending upon the selection, one of the views from any of its cameras. The robot has cameras in its front, the robot has cameras on its right and its left and behind it. The thermal imagery, as the name implies, is a thermographic infrared camera. This allows the robot to operate in the dark. This allows the robot to operate in the rain. This allows the robot to operate in snowy conditions. So in that sense, it has an additional sense. The robot has the ability to see temperature. Thermal imagery allows us to understand the temperature at key components and at key spots on those components, which might be indicative of potential higher voltages, potential higher resistance, and gives us an indication how the equipment is performing. And then it will collect these until the end. Once it's completed its mission or series of mission, all of these images will be saved to the robot's tablet, which can then be viewed later on the computer at a remote location. These will give us an ability to overlay all of these images, and we can see how its visual and its thermal field is changing over the time. If there was a situation where one of these switches opened or there was a rapid temperature change and the robot caught that, what you would see is on that particular image, the temperature would drop or the temperature would be much higher. And you would be able to see that in the charting of the temperature results. I would say within a decade or less that the advancements in technology are going to far exceed what we are looking at here today. We believe we're part of a group of other utilities that are constantly pushing these manufacturers to deliver this because we see the writing on the wall in the future. We would like to have this type of technology to do these inspections in the future.